We're used to seeing things from a particular point of view. That is, from a particular frame of reference. And things look different to us under different circumstances. At the moment, things look
You look peculiar. You're upside down.
No, you're the one that's upside down.
No, you're upside down.
No, I'm not. He's the one that's upside down, isn't he?
Well, let's toss for it.
All right.
Okay. You lose. He's the one that's really upside down. You better come into my frame of reference now.
My frame of reference was inverted from what it usually is. That view of things would be normal for me if I normally walked on my hands.
This represents a frame of reference. Just 3 rods stuck together so that each is at right angles to the other 2. Now I'm going to move in this direction. You see the frame at the same spot on your screen, but you know I'm moving this way because you see the wall moving this way behind me. But how do you know that I'm not standing still and the wall moving? It was the wall that was moving. Now the wall has disappeared, and you have no way of telling whether I am moving or not. But now you know that I'm moving. The point of this is that all motion is relative. In both cases, I was moving relative to the wall, and the wall was moving relative to me.
All motion is relative, but we tend to think of one thing as being fixed and the other thing as being moving. We usually think of the earth as fixed, and walls are usually fixed to the earth, so perhaps you were surprised the first time when it was the wall that was moving and not Dr. Hume. A frame of reference fixed to the earth is the most common frame of reference in which to observe the motion of other things.
This is the frame of reference that you're used to. The frame is fastened to the table. The table is bolted to the floor is anchored in the building, and the building is firmly attached to the earth. Of course, the reason for having 3 rods is the position of any object, such as this ball, can be specified using these 3 reference lines. This reference line points in the direction which we call up, which is a different direction here than it is on the other side of the earth. And these 2 reference lines specify a plane, which we call horizontal or level. In this film, we're going to look at the motion of objects in this earth frame of reference and in other frames of reference moving in different ways relative to the earth part. Now I want you to watch the motion of this white spot. You probably see the spot moving in a circle. But this is what its path is actually like in the earth frame of reference. This is your normal frame of reference. You saw the spot moving in the circle because your eye moved along with the cart. You put yourself in the frame of reference of the moving cart. So you see, it isn't always true that we view motion from the earth frame of reference. When the motion is simpler from the moving frame, you automatically put yourself in that moving frame.